The next point I wanted to talk about is the connections to the column. Oftentimes when people are purchasing columns, they're concerned about what is the connection available for my column to my system. Fortunately, as time has gone on, most of the manufacturers of FPLC systems have standardized their connections to the manifolds on the systems. So what we see these days mostly is 1/16 finger tight for smaller columns, or 1/4 28 finger tight for larger columns. So in the case of our product line, we would recommend for a 1 centimeter column or 1.5 centimeter column, typically for the flow rates that we would anticipate, about 1/16 would be normal, although we do see the larger columns sometimes run at those smaller tubing sizes. The larger columns of 25 millimeter diameter and larger typically are 1/8 inch. So in this particular slide, the tan fitting is a 1/16 finger tight. In the case of our snap columns, we have the 1/4 28 system, which is that blue connector. And for all of our columns, we can use a connector interchangeably, be either 1/16 or 1/8 inch on the same column. So it's got a little bit more flexibility on the column connection end for the folks that are trying to make up those connectors. The next topic that I'd like to cover are Frits. Frits, as we all know, are the device. Every column has one. Its function is to allow easy pass-through of the liquid in question, the buffers, our chromatography buffers, and our injection, but they also are very important to hold back the chromatography media that's inside the column. So we oftentimes walk a very fine line between looking at our Frits and deciding, well, we want the maximum possible Frit porosity because we don't want to restrict the flow through our column by having too tight of Frit porosity. But on the other hand, when we look at a lot of the resins come with a pretty broad range of particle size. So for instance, a 40 micron particle can be purchased from a supplier. And when we look at it, it's 40 micron average particle size, but the range of particle size could be 30 to 60. So if we pick a Frit that has too large a pore size, assuming that everything's 40, our fines and smaller particles are going to jam those Frits up. We're going to have flow restrictions, and we're going to have complications with our chromatography. Conversely, if we want to take the more conservative route and go with a very fine pore size in our Frits, we will find that we have a much higher back pressure, and we have that obstacle to deal with. So we would talk to our customers when people come to us and find out a little bit more information about what resin you're using in your columns, what flow rate you're expecting. And Frits also come in different materials. They can come in polyethylene, they can come in stainless steel, some come in sintered glass, some come even in titanium, or even other materials, depending on what your running and storage buffers might be. We find, as a general rule of thumb, for most aqueous applications, polyethylene Frits are generally well accepted and hold up quite well. They're also easily interchanged in the columns. And for more aggressive solvent applications, we typically step up to stainless steel or sintered glass, or in extreme cases, titanium. And again, those are rare and far between, but we do have those applications from time to time. We oftentimes have people asking us, does it make sense to take Frits out from time to time and sonicate them and reinstall them? We in our company and in our viewpoint, look at Frits as a consumable item. So in our case, we recommend every time a column is repacked, there should be some serious consideration to changing it out for new, as opposed to trying to clean it. There could be some carryover from the prior batch or prior campaign in that column, of some carryover material, or just some carryover pluggage that will not be relieved by sonicating or other cleaning methods. And we look at it as cheap insurance to basically replace those components. Frits and O-rings we look at as normal replacement when we pack in a column.